Okay. Well, we've been working with trigonometry for a little while, so sine, cosine, and tangent specifically. Our focus is on right triangles, and we've been using that to solve for the sides of a triangle. So remember, with our trigonometry, we had an angle, we had one side of the triangle, and we used trigonometry to find the measurement of another side. Well, now we're going to switch that. We're going to do inverse trigonometry. And instead of trying to find a side, we're going to use our same skill to find the angle. So let's just jump right into it. Again, very important that we identify the parts that we're working with, specifically which sides and which angle we're actually looking for. That's still step one. Choosing the correct formula is or ratio is still the next step. And the formulas are not going to change. Just because we're doing inverse trigonometry doesn't mean anything's changing about our formulas. This is simply a change in how we enter it into the calculator. That is the only difference. So our focus for this section is going to be our inverse trig functions, which again you'll find on your calculator: sine to the -1, cosine -1, and tangent -1. Now, typically, if you have a sine button, right above it, it's going to say sine to the -1. And you're going to need a different button on your calculator that says second. Now, again, every calculator is a little bit different. You know, on yours, did you type 30 and then the sine button, or did you hit the sine button and then type 30? Same idea here. It's going to it depends on the calculator. But most calculators, to get to this function, you will type second and then hit the sine button. So you're using the second function of that button, which is usually the opposite function. Okay. All right. That's the only difference in how we use our calculator. Now we want to make sure we are using our calculator correctly, and then we're going to jump right into problem solving. So, again, the trig table, we talked about that in the last lesson. This is programmed into the calculator, so luckily you don't have to do it by hand. So here's what we're going to do. We want to make sure that we're using that calculator correctly. So everybody's calculator is a little bit different. We're going to do A, so we're going to be using the inverse sine function. Now, individually, we have to figure out how our calculator works. You might have to do second sine, then give it the decimal and hit equal. Or you might have to type the decimal, then second sine, then hit equal. So this is going to vary based on your calculator. So you might have to try it more than once. But you have to know how to use your calculator. Our answer here, when we hit that equal sign, we should get 41.99764032, and it'll keep going depending on the calculator. Our directions say round to the 10th, so I'm going to call this answer 42.0 degrees. Now, again, we want to make sure our calculator is in degrees. If it is in a different setting, our answers are going to be very different. And this is clearly just a calculator exercise. I'll explain to you where that decimal is coming from in just a minute. But it makes no difference if we can't use a calculator. So again, we're going to take the inverse cosine of that decimal. Inverse cosine, and I'm coming up with a 78-degree angle. So again, your calculator, this depends on the calculator. One way is 0.2079 then the second button, then the cosine button, and then the equals button. Other calculators will require you to hit second, cosine, then 0.2079, and then the equals button. But those are the two most common ways. So let's keep going, make sure that we can all use our calculator. For the inverse tangent for question C, we get an angle of 52 degrees. Now again, I am rounding to the nearest tenth, but it caused it to bump up to 52.0. For D, I have an angle of 13.6 degrees. For question E, 31.7 degrees. And for question E, 24.6 degrees. Now, remember when we did trig, when we hit that sign button, we got a decimal, we went to the 10,000ths. Notice here, we're giving the calculator that decimal to the 10,000ths. So with regular sign, we gave it the angle and got the decimal. With inverse sign, we give it the decimal to get the angle. We're using it backwards. That's why we have to do the inverse. We have to tell the calculator, right? The calculator expects the angle and gives us the decimal. We have to tell the calculator we're going to do this one backwards. We're going to give you that decimal. You give me the angle. So we're telling the calculator that we're doing it backwards. Think about it like that. To keep it simple, just think about it that way. Now, where did we get that decimal? I'll show you in just a second. But inverse, we're giving the calculator the decimal, and we're going to get the angle. Now, that could be a decimal also, but we're giving it that big decimal. We're getting back the angle. What we're doing is we're giving it the ratio, the comparison of those two sides. So let's tie this together. Like before, we'll look at a worked out example. I'm going to look at my picture and identify the parts. So here's my angle. I have the hypotenuse and the adjacent. So that forces me to use cosine. No choice. Just like before. We're going to fill in the things that we have. Our variable and the two sides that we know. If you knew all three sides, you could use any two of them. Here we know the adjacent and the hypotenuse, so that forces us to use cosine. So fill everything in. Now, all I did was, in my calculator, 16 divided by 38. 16 divided by 38 gave me that decimal. Now notice what we're doing. We're taking these two things and we're swapping them. We're inverting them. That's where we're going to use the cosine -1, and we're giving it the decimal. So just look at what's in the blue box, and it's exactly the same as what we saw in the previous slide, in our previous examples. We did inverse cosine, and gave it the decimal. We got back the angle. When we're doing our work, the reason for it is because we swapped the angle with the decimal, with the ratio. And we're telling the calculator that we did that. So inverse cosine, 0.4211, and we get back our angle of 65.1 degrees. So again, 16 divided by 38 in my calculator, and I just wrote down the 4 digits so that I could type them right back in. Here, I'll offer you a slight shortcut. It's not much, but it is there. Rather than write the decimal just to type it back in, I could let the calculator do the work. So in my second example here, again, I'm swapping the x. Sorry, let me just do that in the same color so you can see it. I'm swapping the x with the fraction. So long as I use my parentheses correctly, instead of typing inverse cosine 0.4211, I could just do inverse cosine and let the calculator get the decimal and do all the work. But make sure that 16 divided by 38 is in parentheses. Otherwise, you might be affected by order of operations if you enter things wrong. Depends when you hit that equal sign. You're changing the order of operations. So put things in parentheses. Make sure that you're controlling the order of operations. And you can see we get the exact same results. So if we're looking for the angle, we're going to use inverse. If we know the angle, we're going to use the regular, right? We know the angle, we're looking for a side, sine, cosine, tangent. We know the sides, we're looking for the angle, inverse sine, inverse cosine, inverse tangent. Let's look at a few examples. Now, again, we're going to follow our directions of rounding to the tenths. We're going to stay consistent. Identify your parts. That's our angle. We have the hypotenuse and the opposite. So we are definitely doing sine. Fill in the 3 variables. Sine, our angle says x. Our opposite is 16, and our hypotenuse is 20. Effectively, what we're doing is we're swapping those. So we have to tell the calculator, hey, we're going to do this backwards. And now, in my calculator, I'm going to do 16 over 20 and take the inverse sine of that. And I get 53.1. Again, everything we're doing is in degrees. Make sure your calculator is in degrees. Sometimes they reset. Now you could do 16 over 20, get 0.8, and then do inverse sine of 0.8. Or again, you could do inverse sine, let the calculator figure out that fraction. So let's look at B. We have our angle, we have our opposite, and we have our adjacent. There is only one formula for us. Tangent of the angle equals opposite over adjacent. So tangent, x degrees, 12 over 13. Sorry. We're swapping these. So tangent, -1, inverse tangent of 12 over 13. And we're going to let the calculator do that work. And we get 42.1 42.7 degrees. Now, if we were looking for the hypotenuse, I could do trig using 42.7 and either sine or cosine, or I could just do Pythagorean theorem. None of our old knowledge goes away. If I was asked to find that other missing side, I could just do Pythagorean theorem. I don't have to do it through trig. But if I know the sides and I want to find the angle, then I need trig. Pythagorean theorem won't do that. Of course, if I want the other angle, now I could just add these two to, and the third angle to 180. So again, our old knowledge about triangles, the angles add to 180. We could use Pythagorean theorem. None of that goes away. Trig is just a different scenario where we don't have enough information to do it with Pythagorean theorem. And Pythagorean theorem will never give us the angles. Let's look at two more. Because again, then we can apply it into, you draw the picture from the word problem. Use trig or Pythagorean theorem or whatever knowledge you need to solve it. But once you draw the picture from the word problem, we can do this. We have our angle. Think about these sides. We have the hypotenuse and the adjacent. So this is a sine question. I'm sorry, cosine question. So we have cosine, angle, adjacent is 10, hypotenuse is 16. We're going to swap them. Inverse cosine of 10 over 16 equals the angle. And we're going to let that calculator do its job. And we get an angle of 51.3 degrees. And for our final example here, think about what trig ratio we're going to use. This is clearly a sine question. We have the opposite and the hypotenuse. So sine x equals 14 over 28. This already looks familiar if we remember some of our other triangle rules, where sometimes one of the legs is, the hypotenuse is 2 times a certain leg. And we find out that this is a 30-degree angle. So remember the short leg and the hypotenuse. The hypotenuse is 2 times the short leg. Well, here we see it going backwards. We know the hypotenuse and that opposite side, we found out the angle was 30. So it ties back into previous lessons as well. All right, time to do some more practice with it. Build it into other examples. Again, multiple triangles are connected. You work from one across the picture. Word problems, draw the picture, then solve. Let's get some more practice with it.